To example 4 now. A particle P moves in a straight line in simple harmonic motion. So we're given simple harmonic. The acceleration is x, or the acceleration is 2 minus 3x. Let's change that, guys, to our lovely form. X dot dot equals minus 3. X take away 2 on 3. Okay. So here we can read off our n squared is 3. Right? Or our n is root 3. Simple. And here is your x naught, your center of motion, is at 2 on 3, guys. So make sure you know that this is going back and forth wherever it is. I don't know what the endpoints are. That's what I mean by you need to know that diagram off by heart. You need to know these things. Do not bluff, alright? Because you can simply pick off information and slot it in. Initially, the particle is at x equals 1, moving with a velocity of that. So at t equals 0, v equals root 5, v equals root 5, and x equals 1. Okay. Using integration, show that the velocity is given by that. Okay. So you know that your x dot dot equals d dx of v squared on 2. And that apparently was 2 minus 3x. Okay. So in other words, d of v squared on 2 equals 2 minus 3x dx. And let's integrate both sides to get v squared on 2 equals 2x minus 3 on 2 x squared plus c. And sub in x equals 1, v equals root 5. Okay, from the initial conditions. So you would calculate that to be 5 on 2 equals 2 minus 3 on 2 plus c. And you do that, that's going to be 8 on 2, 4. C equals 2 in that case. So v squared on 2 equals 2x minus 3 on 2 x squared plus 2. Therefore, v squared equals 4 plus 4x minus 3x squared as required. For part B, to find the amplitude of the motion, okay, so here, I mean, you would be able, the best way to do this is to solve v squared is greater than 0. Okay, this would be the quickest way because you know that any square number has to be greater than or equal to 0. So if you factorize v squared, it equals, factorize v squared, it equals to minus, I think, 3x squared minus 4x minus 4. Alright, I don't know how you guys, factorize your stuff. The slow way, minus, and you'd have to find factors of 3 times minus 4, which is minus 12, that add up to minus 4, which is going to be minus 6 plus 2. So you get 3x squared minus 6x plus 2x minus 4. And you can factorize that. It equals to minus 3x x plus 2, no, x minus 2 plus 2 x minus 2 equals minus 3x plus 2 x minus 2. So here you've got your velocity. It's a frowny. It goes from 2 and minus 3 on 2. Oh, sorry, minus 2 on 3. Remember, our center, that's totally not really proportional. Remember, our center was at 2 on 3. Okay? This distance is your amplitude, and if you draw it out nicely, that 2 there, you'll see that that distance is exactly the same as that distance, which is 4 on 3. Okay. Okay, so that's how we can find amplitude equals 4 on 3. Finding the center of motion, we already found that from the beginning, right? Your x dot dot equals 2 minus 3x equals minus 3, x minus 2 and 3. That's simple. There's your center of motion. Okay. Find the maximum speed of the particle. Your maximum speed. Alright, so, I mean, remember, you found the two things and we found that where it was greater, v squared had to be between there. So your x's had to be between there, sorry. That was your v squared. Now, your max speed happens here, right? At the center. Remember, recall that graph that we first went through in the notes? Your max speed here, your max speed is at the center, okay? So we just got to calculate v at x equals 2 and 3, right? And so you put x equals 2 and 3 into v squared, and that equals 4 plus 4, 2 and 3, minus 3. Let me just rub all this out. 2 and 3 all squared. And that would equal 4 plus 8 on 3 minus 4, 12 on 9. What's that? 12 plus 24, which is 36, minus 12 is 24 on 9. Equals 24. Really? 36, 24. 36. No. Sorry. Times out my 9 is 36 plus 24, which is 60, minus 12, which is 48. Yeah, that makes a bit better. Equals 48 on 9. 48 on 9. That's v squared, right? Take out 16, so that's 16/3. Yep. So using your third, 4 root 3 on 3 meters per second. Example 5. The speed v is given by blah, where x, yeah, okay, blah blah. Prove motion is simple harmonic. Remember, you just have to show x dot dot equals minus n squared x minus x naught. That's where we have to get to. Okay? Alright, so how do we get to that? You're given v squared, so you're just going to do an easy differentiation here. X dot dot equals the derivative of v squared on 2. Okay? And that equals d dx of half 90 minus 12x minus 6x squared. Alright, which equals half, and differentiate that, you get minus 12 minus 12x equals minus 6 minus 6x. Alright, which equals minus 6x plus 1. Alright, which equals minus n squared x minus x naught. Therefore, motion is simple harmonic. Okay? That's all it wanted. Alright. Find its period, center, and amplitude. Alright. So, how would you do it? You would have to go period. Well, your n squared equals 6, so your n is equal to root 6. T is equal to 2 pi on root 6. Well, that's like, what is that? Root 6 on 3 pi seconds. Okay. That's if, yeah. You should just get into a habit of rationalizing. It's good practice anyway. Alright, for the center, crap, I just deleted it, right? But it was minus 6x plus 1. So that's x minus the center. So your x naught equals minus 1. Alright, so that's the center. Alright, and for amplitude, same thing as above. Okay, so v squared equals, well, v squared equals whatever it is. We'll factorize it. Ah, God. 6. 6 comes out of everything. Alright. V squared equals minus 6 x squared plus 2x minus 15 which is equal to minus 6x plus 5x minus 3. And that has to be greater than or equal to 0, right? So just draw it, minus 5 and 3. Obviously the center is at minus 1. We already knew that though, right? And it's that frowny parabola. So that's where it goes through. Anyway, so if your center's there, how far is the amplitude? That's 4 units apart. 4 units that way, 4 units that way. So your amplitude equals 4. And done. Example 6. A particle moves in a straight line, so the displacement is given by that 6 cos squared, and they want us to sketch that. Okay, so ugliness, right? So use that cos squared t equals half of 1 plus cos 2t. Remember that? And using that formula, we're going to change this guy. Alright, and that's going to turn into 3. 1 plus cos 2 of that, which is just pi t. Alright, so what that is it's, and you got, they want you to sketch it from t is 0 to 4. Alright, what actually happens is this guy gets lifted. It's 3 plus 3 cos, right, of pi t. So our normal cos is just like amplified by 3, alright, and it's also lifted by 3, amplified by 3 and lifted by 3. So there it is, and it goes up 3, 6 to 0, alright. Alright, so what happens at, we'll just go t equals 0. That's going to be cos of 0, which is 1. So you're going to start off at this point. And at 1, which is cos of pi, which is minus 1. And so that's 3 minus 3, which is 0. Okay. And so we get like that. Alright, so that's what you get. And then it's asking at what time in the first 4 seconds is the particle at rest. It looks like x dot equals 0 at x equals 1, 2, 3, and 4. Show that the acceleration is minus pi squared x minus 3. So for this you've got x equals 3 plus 3 cos pi t. Your x dot equals, and it's going to be minus 3 pi sine pi t. And then your x dot dot equals minus 3 pi squared cos pi t, which equals minus pi squared 3 cos pi t. And you know from here, right, 3 cos pi t equals x minus 3. So you sub that in. Equals minus pi squared x minus 3. And that's probably what they wanted, yeah? So for part E, find v squared as a function of x. V squared equals n squared, a squared minus x naught all squared. I'm sure that's it. What's your n? Your n is pi squared. What's your a? Your amplitude. Your amplitude is whatever's in front here. That's your a. Remember, you could read that, right? So it's 3 squared, take away, and what's your center of motion? 3 as well. X minus 3 all squared. Okay. Which will equal pi squared, so it'll be 6x, take away x squared. Okay.